Hi, we're back in the lab now for our titration demonstration. Got my lab notebook. It's always useful in the laboratory. We're going to keep that here. And we're going to just look at everything that we have that we're going to use for today's experiment. I'll show this to you individually. So first thing we're going to look at is right here in this bottle. That is 1 molar sodium hydroxide. Sodium hydroxide is a strong base. It's corrosive, so you want to take care in handling it. The other piece of glassware that's useful that we'll discuss is the burette. This is a 50 milliliter burette. It goes from 0 at the top down to 50 at the bottom. So when we record our information, the volume of the burette, we read from top to the bottom. And we're going to be using that today to deliver our sodium hydroxide to an acid. And our acid's contained in this vial right here. It's what we use in our analytical quantitative analysis lab that I teach. And we're gonna be using this today for our titration. And we're going to place our acid in a flask known as an Erlenmeyer flask. Notice it has a tapered type of neck to it. We like these flasks for the titration because they're tapered and there's less chance for spilling outward, and that's important. So we have our sodium hydroxide. That's going to go into our burette. I have a waste beaker, and I have a clamp to hold the burette. So the first thing we're going to do is we're going to put sodium hydroxide into our burette. I'm going to move this back just a little bit so you guys can see it a little bit better. Okay, to do that, what we're going to do is we're going to take a funnel and we're going to place it up here. And we're going to slowly introduce our sodium hydroxide into our burette carefully. And most people like topping it off, going all the way up to the 0 mark. You can actually go to any volume that you desire. So I'm going to just start it right there. There's my sodium hydroxide in my clean burette. I did clean that before I came in. And I'm going to drain just a little bit of it out so that we have no air bubbles. And we have all of our volume in the burette, and we're starting it at 0. We're starting it at the 0 point. So I'm going to mark that in my lab notebook. Our starting volume. And we'll go over our data in a few minutes. 0 milliliters. Let's take some of our unknown acid and weigh it out. We want to try to get about 1 gram. We'll see how much we have in here. So we take a weighing boat and we put it on our trusty balance. And we would tare it. And tearing it, what tearing does, as we described earlier, it sort of takes into account the weight of the weighing boat and sets it at 0. And now we're going to weigh out our acid, and we'll record that in our notebook. So we'll record the mass of our acid. Got a little bit more than I wanted, but that's all good. I got 1.517 grams, and I'm going to record that in my notebook. And again, we'll be going over this data in a few minutes. And we're going to put that into our Erlenmeyer flask carefully. Now, to ensure that all the solid acid is in there, what we would do in Quant Lab, if you take that, is we would rinse the weighing dish out with some water after we've emptied it in, therefore ensuring that all the acid got into our Erlenmeyer flask. And this is a deionized water or distilled water bottle, and I would put that in there also. And now what I'm going to do is just add water. It doesn't matter the volume of water that we add. All that really matters is that we know the mass of the unknown acid that we put in there. So I'm going to put in approximately 50 milliliters, just like you're going to be doing in the virtual experiment. And I'm going to swirl it and make sure that all of my solid acid dissolves. So we can still see we have some solid particles. Probably going to pour out a little bit more so we have enough water. Again, the volume of water does not matter. So I'm adding it's about 50 milliliters now. And so what we would do is we would dissolve it, swirl it. Sometimes if you're working quantitatively in a quant lab, you might have to heat it to cause the solid salt to dissolve completely. So we'll let that dissolve, swirl it around. And we're going to set this up on our burette stand. If you look at the burette stand, it has a black surface on it. And I'm going to use a white paper towel so I can better see the color change. So let's move the camera over just a little bit so you all can see that. Let's put it up here. I think you might be able to see it better. How's this? There we go. That looks a lot better. So we'll let our weak acid dissolve a little bit more. It's an unknown weak acid that reacts 1-to-1 with our base. And I would like you to all see the color change, so I'm going to make sure you all can see this up here. So once it's dissolved completely, again, in a laboratory, you would probably heat it a little bit. So now, when the reaction occurs, we need some way to identify or indicate that we've added just the right number of moles of base to react with the acid. And so what we use is an indicator dye such as phenolphthalein. There's phenolphthalein. And what we do is we usually just add a few drops. What you're going to be adding in your virtual lab is approximately 1 milliliter. So I'm going to add a couple of drops. And now I can start my titration. And so when I do my titration, I'm going to slowly introduce our base. And notice, if you just noticed right there, it did start to change colors just a little bit. Let's add a little bit more. It starts to turn pink, but as we swirl it, the pink color goes away. Add a little bit more. So we get flashes of pink, and we'll keep watching our volume. It's pretty concentrated sodium hydroxide. So it keeps changing to pink and going back to clear. And what we usually do in lab is run one sample rather quickly just to find out the approximate volume, and then do maybe a second sample a little more carefully. So we're starting to see the color change occur more frequently, and it's starting to stay, it's pink. And what we want to do is it to be very faint pink. and to stay that way for about 30 seconds. So you can see it, it's changing back. So we're getting really close because it's starting to stay pink a lot longer. And we don't want to overshoot if we're working quantitatively in Quant Lab. So we're going to slowly add a couple drops. And sometimes what we'll do to get just a single drop, I'll show you a technique that will be really helpful if you take a more advanced class. And that's to try to get a drop on the side like that, and then squirt it in with some DI water. Because remember, it doesn't matter how much deionized water we add, as long as we know the amount of the substance we weighed out in the beginning. Oh, wow, it's really close. So I'm sure you can see how it's starting to stay pink longer. Can you see? I'll see that. And it goes back to clear. So sometimes these are stubborn and they take a little while, but it's a technique that you gotta, it takes time to become an expert at it. And ooh, I'm really close to my endpoint, the color change, and we'll define another term known as the equivalence point. And I think we're there. I actually overshot it. Can you all see how purple that turned? So that's probably a little bit beyond what we would want. If we were doing quantitative measurements in Quant Lab, probably would want to do another sample. So if I read the volume that I've delivered, I've added 7.5 milliliters. So if I started at 0 and I'm down to 7.5, I've added precisely 7.5 milliliters. So we're going to go over some sample calculations in our final video.